Hi, it's Gadget UK here again, back for part 4 of the TerribleFire A4000 board repairs here. There's lots of things being cut out this video because there was just crazy footage, and you've seen it all before. And some of the stuff that we've done to these boards is covered in the live streams. I talk about that a lot throughout this video, but the links to those live streams will be down below, and edited versions will get uploaded to Patreons later. So in terms of the IDE fault that we resolved in the previous video, you can see the _R_W pin there. It's the read-write pin. Now it's the inverse of the read-write pin. On the 68000 processor there will be a read-write pin that indicates whether it's reading or writing to the data bus there. And this is the inverse of it. So yeah, on first inspection, you can look at the schematics there for the IDE and check everything around there and go, oh my god, what's the fault, and you've got to start looking at inputs from elsewhere that come into this. There are some other signals here, look, some address lines, there's the standard read-write pin, look, that's non-inverted. But yeah, that was the problem on the previous board there with the IDE. So I've cleaned up a bit around here, the transistors and the capacitor there, and just given it a bit of a scrub. There's still a lot of dirt around the real-time clock chip there that needs sorting. I've scraped off the pads there going to that cap, but before I fit that cap, I'm just going to see what we can do with this area here. Now all the pads have definitely gone, but the wires have added some flux. So I'm just going to try and tin these wires up if I can. I'll have a drag around and just see what state the wires are in. Because what I'm thinking of doing is mounting the IC on this side here, actually straight to the wires. Use the wires as the solder points and then cut short every other pin to account for the diagonal orientation of every other wire, if that makes sense. You'll see what I mean. Now you see these wires that go to the pads for this capacitor, the trace is detached on both sides even though the wire is okay. So can you see I put a piece of kynar on top of the pad there that goes through the wire to the wires that go on the other side there. Now there's no traces leading to those. It's because it's a multi-layer board, the connections are somewhere in the middle of the board. So hopefully we'll still have a connection there. So I'll get a 47 microfarad cap on there now, and then we'll just power it up and just measure to make sure we've got 5 volts and ground. And we can test connectivity there as well, I guess, before we power it on. Now the silk screen's gone from the board here, so we need to do that at this point actually, so let's just put it on continuity test. This isn't one of the negative rails, so I can say with a certainty that the ground from down there should be sufficient. That's the 5 volts, I think. It must be this one here. Yeah, the ground is the right hand side here in this case. So I trimmed those wires back a bit so the cap would sit perfectly flat. So as you can see, I'm just going to touch the pad and not the cap, and just flow lots of solder. We'll add some flux in a sec. There we go. And we'll do the same over this side. I'm coming in at a weird angle here. That's it. The final thing I need to do is just make sure those wires are actually joined up there as well, but I think they are. Yeah, so what I'm thinking about doing here is clean up these pads a little bit more than they are now, and mounting the chip upside down. I'll overlap it. The VCC pin is up here, so that can just go to via a wire to something around here. But then I'm going to put the pins right onto these traces. I'll bend them right down, so this side here should be super easy to solder. This side here, if I just move the chip a tiny bit, you can see we've got all these wires here. So as long as I bend the pins down in theory and clean these off so I can solder onto them, I should be able to do it. We'll just have a wire for the ground and a wire for the VCC because those aren't on here. The ground one is there, there's no trace going to it, but then each of these will perfectly line up with the pins. So the amazing thing is the fast RAM works on this. I've just removed it for the moment, but I've tested all 16 meg and it works. The only things I needed to do was when I fitted that little chip on the underside, which I'll show you in a sec, it still wasn't working, and I went back and I just checked the connections and I measured between the connection and the trace, and one pin, I think it was actually pin 1, or maybe pin 2, was not, even though it looked like it was soldered on, it wasn't. I just had a bit more flux, a bit more solder, and then tested it again, and we had 12 meg out of the 16 meg, and I thought, okay. The problem is probably this slot here. This is the most dirtiest. So I just cleaned this up. I put a little bit of vinegar on it, toothbrush, and then used the fiberglass pen. Now, I would probably replace these slots ultimately, but like I said, they're £10 each. That's like 50 quid to replace the slots on this. I might actually keep this board myself. I don't know. I mean, it's got the Buster 11, but I think there might be a fault with that. We'll soon find out. Because what's happening now, it passes all the tests in diagram. All 16 meg work, full 2 meg chip. The IDE works. I've reinstated the 245s. I'll show you that in a sec. But the IDE, you know, you can detect the card and it tells you the information about the card. And that seems okay. You know, you see the LED flick when it does that. So that tells me that this system's probably all right if I can get past the yellow screen that this is now displaying with Kickstart 3. Now, if you remove the RAM, which is what I've just done here, remove the chip RAM entirely and test it, you get a green screen. I'll just show you that. So the reason you would want to do this is to test the bridge bridge it. Because if this was just going straight to a yellow screen, it isn't. It does show yellow in a minute, I think, as it flickers. You know, it flicks green a few times, and then occasionally it'll go yellow. Let's try it again. But primarily it's showing green. That shows that in terms of like address decoding stuff is actually pointing to the RAM. It's not like the address decoding is getting confused and it's pointing somewhere else. I mean, there still could be some sort of overlap there though, because just periodically I'm sure I've seen a yellow screen there, but primarily it's green, as you can see. And if I put the sim back in, switch it on, you'll see it goes black as normal, then it goes yellow every single time. Now, I've seen that before. In fact, you probably remember from the previous 4000 video, I think we tested without a Buster chip, and I think it went yellow screen, didn't it? But this yellow screen basically is a general kind of error to do with hardware. It could be all sorts of different things. I think Stephen confirmed something I'd read online, which was that it's an exception in the early boot process, so it's kind of like unhandled. All it can do is give you a colour. Yeah, it doesn't give you any more info than that. You know, it could be all sorts of things, but most likely some sort of conflict on a bus somewhere. So the question is, what? So I think I'm going to do a bit of cleaning up. I'll show you in a minute. There's 245s around the IDE need cleaning up, but that won't be our issue. One thing I do know is I haven't spent a massive amount of time checking every single piece of connectivity around here, and around here, you know, some of the traces that run down here, and maybe even as far as around here, you know, around Buster and stuff. We did reflow. I reflowed some of the pins here, but there might be some more crusty pins around it. So I think we'll just do some more clean-up work, maybe swap the odd cap out while we're at it, and then maybe retest. And there we go, you can see the fudgy fix. It looks a bit dirty, that wire's not exposed, just a little bit of flux on top of the wire there. So I'll give this another clean, I think, in a minute. But you can see, you know, the chip, I just bent the pin, you know, turned it upside down, bent all the pins totally flat so that they could be mounted on the PCB. Bit of flux, you know, and then just flowed the various connections there. The pins are left lifted, you know, they're not joined because there's no pad on this side, where the ground, sorry, I think the ground's on the, it's this side here, that's ground, that's VCC, that's the direction pin, I think, or the output enable pin, I forget which, and then you can see two wires here, because even though they are joined onto the connection to here, there were some breaks, as I pointed out, on the actual traces. One of them we were aware of, it was like the fourth one down here, but then this, surprisingly, we had another one, even though it's soldered, definitely clearly onto the wire there, which goes to the trace that should come down here. It wasn't making a connection. So yeah, that was all that was needed. I mean, like I say, it looks a bit of a mess at the moment because it's still a bit fluxy, but as you can see, you know, that's done the job. So as long as there's enough clearance in the case with the standoffs, and I think there is, you know, the point that the when this goes into a 4000 case, you've got like a lump that sits there. This is going to be well above that area. You could just put a piece of Captain tape over it or something, but I'm sure that's going to be fine. So one useful thing I guess I could point out, the hard part, these are easy to solder when you can see around them. The hard part is this side here is near impossible to see down there whether you've got a flow from the pin down to the pad. You know, you should have like a, you know, it should look nice and silvery all the way down to the pad there, and it should be, you know, like a slope. It should slope down towards the PCB edge. Using this little dental mirror here, see if I can show you this. Yeah, hopefully you can see that, just using that cheap dental mirror there. you'll get something like that for £1 off eBay, so that's really useful when you want to inspect the inside of that. And when you do reflow this, do what I did, stick some Captain tape over there, because you're going to get the irons super close to that connector. So I'm sorry I didn't show you a lot of the stuff I did yesterday. I've just spent so much time on these boards, and you've seen it before. I've shown removing these chips and soldering them on lots of the Neo Geo boards. On the part 1 you'll have seen replacement of some of these SMD ICs here, so there's no point in showing you the same sort of thing over and over again. Even just fast forwarding through it, it just creates more footage for me to edit, and I'm sure you get bored watching exactly the same sorts of things. But the progress stages, I guess, are informative and useful, I guess, if you're going to work on one of these yourself. So I'm amazed with the progress. Yesterday, it came on leaps and bounds. Since this arrived, this board was doing nothing at all. I never got a single boot out of this board. And then removed the pals and things here to get the other board working. I left them off it because looking at the schematics I was like, these are all just IDE related, it's not important, I'm sure it won't cause a problem with the boot. What I didn't realise, I think both of these have a connection to the DTAC1 connection, which goes down to Gary being a gate array, not just a floppy controller as I've mentioned in the past. It's a gate array, it has all sorts of stuff going through it. That DTAC1 signal is probably, well, definitely essential to the boot process. The processor probably, or something on the board can't boot without that DTAC1 signal, for sure. I don't know much about how the DTAC signal's used on a 68000, and obviously I think there's this DTAC1, it might be the DTAC signal, but with some sort of phase shift or something, I honestly do not know. I'm sure Stephen could post, or somebody more experienced could post down below what that DTAC1 signal is used for. I'm guessing it's some sort of, I think it's a data transfer acknowledgement signal or something, isn't it? Probably. Within an hour, suddenly got it booting. Not only that, I then put these back on. We had IDE. Then I stuck that chip on the underside, as you saw, and we suddenly got RAM. It's amazing how quickly this one's come on. Now there's a lot of corrosion around the audio section, so the audio's, and I know it's not working right, I've tested the sound is working but only on one channel, and all the caps around there are all well leaked. I could find my own case and build it into a case. The only thing I'm lacking is a bridge board. So I'm seeing those on eBay at the moment, like £200 from Analogic UK, which is extortionate. So I thought I'd show you this one. This is the hard one. It is stuck on both sides. It looks like it's lifted up on this side, but it isn't. It's just the dome of the cap has come off. Well and truly stuck on there. There we go. Look at its legs there underneath. They're kind of like it's blade outwards. I think it's had a knock as well as leaking. So let's get this thing off now. In order to get this off, you've got to take the nuts off here first. So you could use some pliers, but I've got a special tool here that just assists. So I've got all the nuts off. This should now sort of come off. There you go. It's kind of corroded on. Look, the state of that. Good God. Anyway, we'll clean that up with a fiberglass pen after. So exactly the same thing you saw me do in the previous video here. We'll start with these anchor points that are a pain. So I've shown a lot of this stuff before, but one additional tip I'll give you. This Chemtronics desolder braid is really good. Not all desolder braids are equal. This has got like a flux core, I think, and it says there no clean. I think it was Retro Game Mods that originally recommended that to me, but I think in recent times it might have been Dermot Sweeney or somebody else who pointed me towards that. Could have been Dave Curran. Anyway, you can see the solder came off really well using that desolder braid there. I thought that was going to be harder than it's actually turned out. So you can see how it's come off. Look, bits of plastic sheared off there, a bit of white plastic. It's well and truly corroded. You've got to be careful here, because you can see these little cutouts. You can break this off if you're not careful. There we go. Look at the state of that. So that was the worst I've ever had the misfortune to have to remove. You can see the pad there went, but it's just, you know, these are joined on this side, so this is easy to fix these. Now I think when I sent that one back to Cathers, as you'll see in part 4, it got damaged in transit, and he had to replace one of the sockets, and he lost a pad like this. But the trace just goes from this component here to here, so you could just literally just blob a bit of solder across that connection there. The one over here I think goes up there, so I might just stick a wire to that actually. But yeah, the pads have come out largely okay. We've obviously lost through holes with those as well. So as I say, we'll clean this side with a little bit of vinegar initially, and then I'll get the fiberglass pen on there. All the silk screen's coming off. Can you see this? It's like all the letters are all sliding around. So I've cleaned around here with the fiberglass pen. Can you see it's gone all copperish? That's because the solder mask, sorry, not the solder mask, the solder coating has just kind of worn off a little bit. So I'm just going to get a little bit of flux in a few places here, not a lot. Don't need masses of it. And I'm going to tin this lot up actually. You know, you can see here it's looking a bit pink as well, so we've got some there. There we go, so we're ready for these to go back on. There we go, got the couple of fixed wires on there. Just need to clean that up with some IPA. The next thing I'm going to do is fit the audio sockets though before I clean up, and then we'll clean both lots up at once. So here's the old one. Now the interesting thing with these came from Amiga kit again, just like the ones from Cathers board, and they're pretty much the same. The only difference, well, there is a bit of a difference. You can see these ones are the old one's kind of bent this way, and that one's bent that way. So you do, even with these ones, you've got to bend that way a bit. It's probably almost right now, I think. So I'll try and show you some of the cleanup work here. You can see the side of this chip here looks nice and clean. Now I've got replacements for some of these chips, and I'll probably end up, I don't know whether I'll keep this board or whether Stephen will want this board. But what I tend to do is go over the pins really carefully, usually under magnification like this, to get the green crystallised stuff off there. Because there's like a coating that even the fiberglass brush struggles with. And then go over it with the fiberglass pen. And apologies, I'm doing this left-handed and blocking the shot here. So, and I'm not using magnification. But hopefully you can see the pin's an awful lot cleaner there now. So by the time we've, I'm going to cover over these copper bits here with some desolder braid. Use some desolder braid with a bit of solder on it to tin them up. Get some flux on these and reflow them. But I'll do the same with those transistors there. Clean the legs up on those, and then reflow those, and just show you that it should look, super clean when I'm done. There's a bit of crusty solder here that needs removing. This is the super time-consuming part, actually, cleaning up all around the audio section here. So, kid you not, about 2 hours later. So you can see round here it's looking super clean. I've cleaned up, I removed all the old crusty solder from here, reflowed these, cleaned them with a fiberglass pen, cleaned all these wires, flowed solder over these wires using the solder braid there, reflowed these components, replaced this connector because it was a bit melted on one side from me not removing it. I should have removed it before I start doing the work here anyway, so I've replaced that, brand new gold plate connector. We lost a pad here because I was slightly aggressive with the cotton bud, and I didn't realise. I was like, wiggle, 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 what's that there? That looks a bit weird, and then it just snapped off. So we did lose that. I need to reflow these things here still, and some of these caps here. There's the odd little bit exposed that I'll try and tin up afterwards, but the main thing is this bit here is now okay, so I'm going to get the new connectors on there. And I've remembered the other adjustment. Can you see from new they're totally square, and look at these here, they're bent inwards, they come inwards. So yeah, I need to bend those again. So I'll show you some of this as I reintroduce these caps. I use the soldering iron to remove them with the solder sucker, and then I just unblock the holes with the solder sucker because there was a little bit of solder there. I did have to pull one side through with a bit of heat. And we'll just reflow those again to get some sharper solder points after having cut them. There we go, that's that one. It just needs a little bit of adjustment, I think. Yeah, the side towards me just needs pressing just a tiny little bit. Yeah, there you go, you can see that one's done. So I'm going to do this. I'm going to do this left-handed, and I am not ambidextrous. Well, maybe this proves I am. Let's try. Oh, it's moved. Look, this is the problem with trying to do it left-handed and not using magnification. Yeah, that's alright. Managed to straighten that. So after you've tried to solder something like that and failed miserably, what I would do is, we've already got the flux on there, just use the desolder braid and actually, I need to be careful, I don't want to melt that mouse port, suck up all of the old crusty solder, but at the same time you can kind of slide up and down a little bit and you'll tin the corroded pad. As long as you're not using too much heat, you won't lose any pads. You see that one's clean now, and that one's clean, look, can you see that? So despite having recapped this, we've still not got audio on one side. So the first thing I'm going to do, you can't see this diagram very well, the output from Paul here going into a couple of pins on the op amp. One's pin 9 I think, and the other one's pin 13. So I can't show you everything at once here. What I'm going to do is probe pin 1 and then pin 7, so the end pins on either side there of that chip. So start with pin 1 there. Can you see that little sine wave? I'll just pull it away, put it back on pin 1. You can see it, and if I press click here, hang on, yeah, you can hear the audio go off. Click, audio back. I'm switching channel 1 off and on there. So channel 2, let's look at pin 7. Again, you can see there's output from that op amp, and if I turn its channel off, hang on, I need to go down 1. Click, it's gone off. You can still hear the TV because that's channel 1. It might help if I switch channel 1 off. So that's channel 1 off. So channel 2's on, channel 2's off. So the primary op amp there, the initial op amp, is working. Something to do with the output stage. So the points we were probing here was pin 7. This is the one that's not outputting audio at all, and pin 1. So the next stage is the LM833. So I just need to, I'm going to probe the outputs of these, but I'm guessing it's not making it through this 10k resistor. That's probably what the issue is. So scoping the small op amp there, so you can hear the working channel. I'll show you that. As you can see, we've got sine wave coming out, And if I switch that channel off and switch the other channel on, and if I probe the other pin, yeah, you'll see it's completely flat. There's nothing there at all. So it looks like I'm probing the outputs there, by the way. The outputs of the small op amp. So it looks like that little 8-pin device is the issue. So this little clip I've added in at the end, so this is the other board actually, but it was this little chip here on the one board that was the fault there. So despite everything seemingly being okay with this board in terms of diagram, with Kickstart, as you see, it boots to a yellow screen. Then it kind of like resets, goes black screen. So I'm not sure what's going on, but Buster was my first thought there. Now I've tested the connectivity to one of the GALs that's nearby, and that's okay. The connections around Buster look okay. So I could be completely barking up the wrong tree here, but my eyes are fixed on these F245s here, because these are the buffers that sit, the 74 F245s that sit between the data bus side that comes out of Buster and the in Bridget. Now it could be probably Bridget, but I think I've kind of ruled that out. Well, I might have ruled some of that out in terms of the sense if you remove the chip RAM tester, you get a green screen. So that shows that there's not something crazy going on there where they're both trying to be addressed at the same time. But there could be an issue with the the read from the Buster side into the Bridget. So the Bridget could still be the issue. It could be some of these other chips up here that feed the connections and some of the data lines and things that go through here. But these sit on the data bus. So if we probe these, can you see activity there on each one? And you can see it flickers and there's like a pattern to it. And if I show you these ones down here as well, you can see it's like pulses, and then you get like a, I don't know, like a pattern of the flickering going on. It's certainly bi-directional because you're seeing highs and lows. That's the thing I'm trying to point out here, I guess. Some are pulsing more than others, they pulse for a period of time. But one connection up here, I forget where it is now, it kind of sticks high afterwards. Let me just see if I can show you. Was it that one? Yeah, you see that? That's high. It's like sticks on high. I'm not really sure what's going on there, if I'm honest. I think at this point the CPU's probably crashed. Be interesting to check the outputs there on the black screen. And I'm not sure which side this is. That one there's high. That one's low. Got two highs there. Anyway, so we've got two highs there, two lows there on those bottom two pins. So neither of those are warm. What I'm thinking of doing is just removing these one at a time with the hot air, testing it without them, because I think, in theory, that just isolates Buster, the Buster data side of things. Well, it's not really coming from Buster. Well, maybe it is actually, I'm not sure. But anyway, it'll remove these from the data bus. So I think that might just get us past the yellow screen. If it does, we know that it's something to do with this area of the circuit here, just by virtue of removing these. It might be the chips themselves, it could be the control signals that enable these and change the direction at various points. We can look into that then. It could also be the Buster. We might need to get a socket on there and replace that Buster. Yeah, it's starting to come up. It's just stuck in the corner there, I think. There we go, that's one off. So it was exactly the same after doing that. So I'm not really sure whether that is a valid test or not. Maybe we could still get the yellow screen because we've got a floating bus here now. When it's trying to read from that the data bus there, if you've got no IC there, it's floating, you're going to get weird values, There we go, that's one. Same thing over here, try and touch the pad, not the pin. There we go. I've tested an incredible amount of functionality around this area on that other board. You know, on the other board, the buster is soldered on. I can't help but wonder if it's the buster. And we swapped a few buffers and things around there, you know, try, you know, to see whether that would solve it. But there's just guesswork. So on the other one, I might ultimately have to take the buster off and try this one. You know, put a socket on the other board and put this one on that one. But the real-time clock's not working on the other one either. And I think in both instances I'd like to remove the chip here just to clean up around it, to get a socket on if anything, and then at least these two chips are socketed and I can work out if either of those chips are the fault, certainly on this board, because on this board I think that chip is actually the issue, because it's had a new 174. I might be getting confused and thinking of the other board, I don't know, but anyway, one of them's had a new 174 down here, if not both of them. So I'm going to desolder the real-time clock chip here on both boards, and then we're just going to retest and reevaluate to see if that solves any of the problems. Now you might be thinking, well, that's a bit crazy, but not necessarily, because this has, I think, 3 or 4 data bits here that are on the main data bus. So if something goes wrong with this and this starts occasionally outputting 1 bit, you know, 1 bit here is flickering a little bit, it's trying to go high, yeah, you might find for the most part some things work and then other things are not quite strong on the data bus. This might be blooming well interfering. This could be the problem with the yellow screen on the other board. We're thinking it's buster, and it probably is buster, but it might not be. So just right now, at this point in time, I'm just going to remove, as I say, the chip on both. Sweet. Right, there's 2 different chips here. I'm going to put back in the one that I believe was on this board. Now this is, hang on, if I carefully get it into the slot. So I've carefully got that chip into its socket, and if I switch it on, you'll see, hopefully, it should start behaving the same way it was doing before, when I had these really weird things going on. In fact, I'm not sure it has. It will boot the first time or the second time or even the third time okay, as it's done here. And it's got 16 meg fast. Nah, it starts to play up. There you go. Can you see the lines at the bottom here? And you can see the corruptions up here as well. This is exactly what it was doing. And after it's been on, let's say, as you can see here, a minute or two, it starts to become consistent. Where, watch, hang on, I'm sure it'll do it again. Oh, it hasn't done. But it starts to be fairly consistent, especially after it's been warmed up. Yeah, it's done it again at the top. You can see some corruptions up here. I think that's on, right, and if I choose step in 10 tracks, let's try that. Nothing. Step out 10 tracks. There we go. Do you see it move? Step out 10 tracks. 10 tracks. You can see the head moving. The other board is not doing this, which leads me to believe there's something wrong with the CAA, and that might be why it's given a yellow screen. I don't think so. It might be it's got 2 problems. It might be that it's got a CAA fault and it's got something wrong with Buster. And it might not necessarily be the Buster chip, it could be some of the supporting stuff and logic around it. There we go, it's off. It's off. So there's lots of ways you could do this, but as you can see, what I've done here is, sorry the camera's wobbling a little bit, I've fed 2 pieces of Kynar. Can you see they're extended at the moment? I'll chop them off, but they've been soldered on this side to the via super tidy. The reason I've left a bit of length is because when you heat the other side, if it comes loose, this is not going to come off. Does that make sense? Because then you can re-secure it on this side when you've done soldering on the other side. All will make sense hopefully in a minute. So on this side here, this looks really scary at the moment, mainly because of the mess over here. But and I can't get the tool in the right angle, but what I've got here is the Kynar I've just pushed through here. We can literally just grab it, bend it at the point it's coming out as flat as possible. I press it right down. So can you see that? It's extended out a little bit at the moment, so I'm just going to chop that off to approximately the length of the pad, or the pad that's next to it, and then we can just straighten it a little bit. All of these pads on this side are floating, by the way. It's not due to some bad removal. I'm sure the way I removed it perhaps wasn't ideal, considering the damage that had been done to this area, but they're all flowing on this side. The other side, they're all no problems at all, and it's no surprise because they're so close to where the battery was. Anyway, you can see that now, that's totally flat. So we've got all of the pads there. We've got one missing here, but that joins to a trace here. So I'm going to have a wire coming on the top side here, so I'm not bothered about anything there for the moment. I'll stick the chip on, and then we've just got this little, we'll stick a little wire, piece of kynar from there to this trace. I'll perhaps scratch it off a bit and just join it up there. So we can get the chip back on now. So I guess I am kind of moving in a positive direction here. I've proven that one of those real-time clock chips is faulty. They might both have an issue because both these boards behave the same way now. You can see some green marks on here. This is where I've tested all the connections of that side, that side, that side, that side. This chip entirely, this one entirely, this one entirely. These have been checked previously, but I'll check them again. Just try and get to the bottom of the yellow screen because, you know, I've been swapping these 245s here like a crazy person. And you know what? It could just be a missed trace somewhere around here. There were one or two down here next to Buster, but I'm going to check those. They seem alright, but I'll recheck them again. In the meantime, I've ordered some replacement real-time clock chips for this, but the issue could be, because both these boards behave the same, the issue could be the 174 here, because despite the fact on both of these boards I've replaced that, I've replaced it with a HC174, not HCT174, and that was, you know, I thought maybe I could get away with it. I'm not so sure because both boards behave the same with the chip that doesn't kill the system. I'll demonstrate that in a minute. This board originally had the one that was killing it intermittently, especially when it warmed up. So I'll show you that behaviour in a sec. So on the board that's yellow screening, I've finally got audio. I'll show you. So left channel, we had this already, this channel was working. It's actually coming out the right side of the TV. The other channel, this one wasn't. Sweet. So the answer was actually the little op amp at the edge of the board there. So I think the only issue on this board is probably the yellow screen now, but I am waiting for a real-time clock chip for it as well. I really don't like working on the audio section on these because there's so many components packed into such a small area. So I'm just going to use the solder pump here actually. Let's remove this. So the middle part of this repair was done across a number of live streams actually, so it's well worth checking out the live streams, which I'll link to down below, because there's quite an extensive amount of things I needed to do to this board. Now this is the one where I fitted a Buster socket and it was playing up when I came to test the hard disk initially. It wouldn't boot, and after reseating the IDE and me doing some work to the IDE connector later on, I thought I'd resolved it, but it's quite warm today. I've tested this for the first time in a few days. It's probably warmer than it's been in the last month actually, and it's not booting. So using diagram here, you can see we've got some corrupted data coming back there when it's reading it. So it sees the drive, the LED flashes, but it's getting the incorrect data there. So I'm thinking the 245 bus transceivers, because this has got a set of the original ones that were on one of these boards. I think they're on the other board originally actually, so in fact they may have been on this board, and this I think is the one that originally had some sort of IDE issue. So I think I'm going to swap those over next. I'm sorry I've not covered removing that chip, but you can see plenty of examples, perhaps within this series here, but also in the live streams as well. We'll just clean off the solder from these pads here, and I'll get a new one on and retest it. So as I say, I've not been able to boot this board with Kickstart, from the hard disk at all today. I tried a number of times. I tried a different adapter, tried a different Kickstart, compact flash card. No joy. I tried the other board. The other board works fine with both both of the adapters and both of the cards. So clearly there is something going on. I mean, the main thing is it's seeing the drive. We see the LED flash, which, as I said, leads me to believe that maybe this is what's going on here. And I'll drop that right down there now, and just add copious amounts of solder. It's not flowing very well, is it? Just about done it there. Yeah, I'm not worried about the size of that blob there. We'll just do the same up here, try and avoid moving the chip. Let's try again. It's not flowing very well. I don't know what's going on here with the flux. Let's just clean my tip. Let's try that again. There we go, that's flowing now. So just press it down, reflow that. Woohoo, I think I hit it first time. You see here it's saying CF card again, and it's got the correct version number. So I'll stick the Kickstart ROMs back in and we'll see if that'll boot up. There we go, running from the hard disk, no issues. Just found a bad connection as well around one of the 166s to do with the serialisation of the jumpers there. You can see it saying AGA Alice with bad lease ID. And you can see the hexadecimal values of those, so those are incorrect. And I've just worked out, I'll show you what it is. Yeah, apologies you can't really see from the distance here, but the third pin along the bottom here is floating on that top IC, and this is the one that's reading the options. Actually, the pin below it is okay, that's showing a ground at the moment. So, yeah, I just need to add a little bit of solder in there, reflow that. I'll retest it again in a minute. So there's been a massive jump cut here. This board is literally about to go back to Stephen Leary, actually. You can see this one's got a 1 label on it, and the other board has been marked A for A-hole. Now, if you've been watching the live streams I've been doing, because the live streams came up before the initial, these two parts of the video you've seen here. On the live streams, there's been a lot of work to these boards, finishing them off. The yellow screen that you saw earlier, I removed the chip here. You can see that's socketed now. There's been lots of work to these boards. This is the better board. There's less work here. It's less scary in the area up here. I'll show you in a minute. I'm going to clean this up now and get this sent back to Stephen. But what I would do is I'd invite you to watch some of the live streams. I'll put links to them down below, because those I would say there was a lot of work went into those, finishing these boards off. There were numerous issues, as you will see. We had some faults in this area here, so you might find some useful information by watching the live streams in terms of how to diagnose faults around there and the sort of behaviour you may get. And some faults around the IDE section here as well, in terms of how long it was taking to boot, some failed boots from hard disk, etc. And also the stuff to do with the yellow screen. That was really interesting, and you could see me removing the chip, fitting the socket, diagnosing the faults because it was still yellow screening at that point. So yeah, do check out the live streams. They're quite long, but you could watch them in bits every now and again if you wanted to catch up to see the remainder of this series, because there's been an incredible amount of work done to these boards. So just on the final clean-up work here now, there's just a few bits of the board where I just need to go over gently with cotton buds just to get the odd mark off and stuff. I'll clean the tops of some of the chips where they've got little bits of marks from probably me handling the board more than anything. I will also need to remove any bits of fluff and fibres and things, because obviously I've got cats here, and you do get the odd hair stuck on a board like this in this kind of environment. You want to be working in a clean room or something, really, really clean area. The way I do that, and it sounds crazy, but I'm going to clean the board as I'm doing here, and then you can either hoover it, but that can generate static, or I just get my tool, stick a bit of sellotape wrapped around it so that the tape's on the outside, and I can just literally, using a magnifier, find the bits of hairs, the fibres, because they come off from cotton buds, and just touch it, wherever they are, and they come off and they stick off into that. So I'll do that just to make sure it's fibre free, there's no hairs or anything on there, and there's no marks or anything on anything. But yeah, this board is pretty much ready to go back to Stephen. it could be, I could spend more time on this. I've had to draw the line somewhere. It's fully functioning, everything works. I've tested, as you may see if you watch some of the streams, the serial parallel ports are fine. The only thing I can't test here is the Zorro cards and things, but I've got no reason to believe there would be a fault there. I mean, there could be, but there's not. I can't do anything about that. If Stephen's got a fault there, he can either send it back to me with a riser so that I can test and maybe fix that, or he could have a go at fixing it himself. I'm sure he's, well, I know he's more than capable of fixing these things. It was more about time, I think, than anything. But with the lockdown, you never know if there is a riser fault or something, something to do with one of the chips around Buster there, to do the address or date lines. He could maybe have a look at that himself, or I could have a look at it again in future, either way. But in general, I'm very pleased with the end result. You can see it's not bad. It's not bad. With minimal amount of wires on here, the option jump I've reinstalled. So this is the board I've chosen to give back to Stephen, and there are a few reasons for that. The SIM slots are a lot better. All the SIMs clip in okay. I did have to, can you see here, someone's melted this previously when they've had the TerribleFire accident around here. So I had to smooth these down and flatten them off a little bit with a file, because they were just all over the place. The plastic was awful. But as you can see from the top, the profile's pretty blooming good, actually. So, there's the odd chip like that I couldn't really get very much access to the inside there. So I've reflowed it, and it looks alright, but the solder looks not perfect. But it's reflowed okay. There's lots of damage where we lost the pads and things, or there's marks from the corrosion. The corrosion around this area here was not too bad on this board. On the audio side of things, hopefully you can see, there might be the odd fibre there. I haven't got rid of the fibres yet. But yeah, it's pretty good. And it's fully functional, that's the thing. On this one, because there was a lot of corrosion up here, the sockets, there's a wire. Can you see that black wire? There's one wire there going to one of the connections on that. So, and it's the same thing I've talked about before, where there's these replacement connectors here from Amiga kit. Whilst they're nice gold-plated new connectors, you do have to bend them a fair bit to try and manipulate them and get them to sit on the board properly. So, if you were to put this back into an A4000, it might be a tight fit. I don't know, you can see that. Can you see the metal part here is just bent outwards a little bit? It's hard to know whether that would be a problem or not, but I think Stephen's intentions for this board are to literally have it on a mat and use it as his prototype tester. So any hardware he's developing himself, this board hopefully will be part and parcel of that. So it won't probably be going back into a case, but that's the only point I would make. The thing I'm not happy about, if you like, that these might need some adjustment if you were to try and put this back into a case. I cleaned up this on, I showed some of it on the streams and things. These were super rusted and corroded, so that's come out pretty good. It looks a bit uneven and stuff. It's a bit pitted in places. Both of them are the same on both boards. The other one's worse, actually, the one I've got, the one I'll be keeping to myself. It is worth watching those streams because there were a number of issues, including finishing off the real-time clock stuff. I haven't really talked about it towards the back end of this video here. I can summarise, swapping the chips out there, solved that on both of them. That was the remaining thing. It was the ICs there. But there were also some interesting issues with the IDE. You saw earlier in this series here that one of these chips here was causing it to not identify the ID, the IDE card properly, the compact flash card, and it was given an error. It was intermittent, so that's why we swapped one of those. But there was another interesting issue with the parts that I'd fitted onto both boards here. One of them had 2 of those chips replaced, and the other one, this one here, just had 1. So there was some interesting stuff on the streams about those, and about the IDE terminators that you can get for these. So it's well worth watching those streams for that. And on the underside of the board here, you can see it's looking pretty clean. There's the odd trace like that there. You may think, well, maybe I should tin it up, but actually it looks okay on both sides, and it's all been thoroughly cleaned with vinegar and stuff. And these have been in use now, these 2 boards, since March. I finished fixing this one in March, really. It's just been stuff on the streams you've seen since. So, and they've had quite a lot of use. No problems at all, 100% reliability. So you can see that's how that area's ended up there. Yeah, it could be tidier maybe, but it was a nice alternative way to deal with, the fact that the pads have been ripped off on the other side. Now, there are a few points that I'd like to make with this. There's different ways of achieving a similar sort of result. I turned this upside down and bent the pins downwards, yeah, mounted it upside down. That kind of just meant that it was almost like a one-to-one mapping in terms of the pins. There's just the odd things you can see here, a couple of fixed wires here where they were broken. Solder blobs are a bit big on there, I might just shrink those down a bit in a minute, but you know what, it's not really a big deal. So the other thing you might be thinking is you might be able to mount the chip the right way up and flip it round the other way or something and maybe just invert the direction signal. The problem there is on these chips, the way the pins, they go diagonally. So it's like you have an input on one, let's say that first pin there, it probably isn't, but and then it goes, instead of the opposite side, it's not, it's the one next to it. So as soon as you flip the orientation round, that diagonal orientation issue becomes a problem. So you can't easily deal with it that way. I think I went with the easiest approach for me personally to invert the chip here, just bend the pins down. But you could, if you're not careful bending them, you could break them off. They're pretty fragile, and you can see the solder points here are really super fine. Let me get a little bit closer. Yeah, so there's hardly anything to join onto, but I know this is super reliable. It's been used for probably 3 months or so now, no problems at all. And coming back to the live streams again, there were some interesting issues to do with different versions of Kickstart as well. One thing that I can now say towards the end of this video, 100% certain, when you boot WHD load games with the Kickstart 3 ROMs that Stephen provided, this one's currently got my Kickstart 3.1, but when you boot with the 3 ROMs that Stephen provided, with the compact flash I've got, it's a 50-50 as to whether the game will black screen after it comes up with the splash screen for WHD load. And I've proven 100%, like I say, you put Kickstart 3.1 ROMs in, that doesn't happen. I can boot every single game from my compact flash card image 100% of the time, no issues at all. And that behaviour transferred between boards. As soon as I swapped the ROMs over like this and put the Kickstart 3 ROMs on the other board, I started to see the same behaviour on the other board, where 50% of the time I would get a black screen when I launched, say, Pinball Illusions, for example. I could reboot it again, try the same thing, the splash screen would come up, then the game would start. But as soon as you put Kickstart 3.1 ROMs in there, that problem goes away. So yeah, that was covered on the streams as well. Along with stuff to do with the boot times and things for those, which tied into some of the IDE stuff we looked at on those streams as well. Yeah, so you're probably not going to be able to see what I wanted to show you, but like on the ports down here, there's just the odd fibre. This is one reason why I talk about lint-free cotton swabs, and I may well end up getting some myself. There's just the odd fibre around there that has rubbed off. Yeah, and you can stick them up like this, My fear with this is that Stephen's going to get this under the microscope. I hope to God he doesn't, because yeah, some of the soldering, it's not great. I've done the best I can. I haven't got microscope here myself, so it's very difficult to do some of the small repairs that you need to do to something like this. But I think in general, I'm happy with the way this board has come out. It's come out really well. And the main thing obviously is it's 100% functional. Real-time clock chip replaced, all the capacitors replaced, CR2032 mod, the 174 down here replaced, 161 replaced, this 161, not 161, 166, this 166 here is okay. So again, some of the stuff on the streams, we covered some issues to do with the mouse around here as well on one of the boards that was a bit intermittent. It was actually the other board, the A board. Reflowed pretty much everything around here. The exception is I cleaned up around Alice here and Paula, but it's one of those questionable things. Should I reflow it? Should I not reflow it? You could, if Stephen wanted to, he could get a bit of flux on there and reflow those sides there and maybe reflow Paula. I think I did this side of Paula earlier actually, but the other side perhaps not. So the caps were all replaced around here, lots of tinning up. A brand new 3-pin connector there, because that was super corroded. That's for your CD audio mixing. Brand new connectors, and the op-amp there was the final piece of the puzzle on the audio section on this one. One of the 245s was glitchy on this one. It was intermittent. When it warmed up a bit, it stopped reading the compact flash card. These did come off here at one point early in the video when we tried to diagnose the IDE problem with the other board. So as we saw earlier on, one of these was causing the IDE faults, but the other chip was the issue with the buster. So this is now being socketed up. I think this is the Rev 11. I'm going to send this back with a Rev 11 buster to Stephen because it's the more expensive chip. I would feel a bit guilty if I kept the Rev 11 buster myself, but both of them are socketed now, so I could have kept it if I wanted to. But I'll just buy one of these. They are pretty pricey. They're like £50 from Analogic in the UK here. It's worth watching those streams to see how to remove the chip and fit in the socket and everything. It was a little bit bowed, only a tiny little bit, but when I compare it to the original socket fitted by Commodore on the other board, and I can perhaps briefly show you that, can you see Here it's a little bit bowed, and down here, look at the bottom. Yeah, so they bow a little bit anyway, or bow, say it how you want. I've tested the LEDs here. We tested the floppy interface here, the external floppy drive interface, on some of the streams as well, and I looked at an issue with some external floppy drives and a problem with the jumper on one of these as well. That involved probing around the CIA, so it's well worth looking at that particular stream. So I'll take my Kickstart 3.1 ROMs out, put his 3 back in. I'll remove my fast RAM as well. The chip RAM is what Stephen provided, so that can go back with that board. And again, on those streams, I got a SIM for my, for the board I'm keeping myself. So I talk a little bit about that. How, what type of SIM you need there. So again, look at those streams for more information. So let's have a quick game of one player. You can get this on the Mega Drive, can't you? It's not a bad game, actually. First saw this on Jamie Morgan's channel, Morgan Just Games. Yeah, it's very arcadey, isometric shooter. As you can see there, that's working fine. Sweet. So this looks pretty cool. James Pond 3. I didn't realise there was a third game. He looks a bit bigger there. The sprite's huge. I'm sure it's bigger than it is in James Pond 1 and 2. Wow, look at the speed that goes. You can compete with the Mega Drive, the speed that moves up. What do you do these now? Oh, that's weird. Yeah, they've totally changed it, haven't they? Oh. Anyway, that is working. Bit of Operation Thunderball. I like the Amiga version of this. The ST version is very good as well, actually. And there's a fantastic version of this game on the Super Nintendo. I skipped the speech thing there. Yeah, to start with, you can't see the cursor, can you? You've got to kind of just go off practice, knowing where the cursor is as you move. But you can get like a little infrared dot thing to help you aim.
Made contact with intelligent agent and obtained information.
So the other board went back to Stephen. This is the A board. Now I'm not sure if you're going to be able to see this. I might need to get you on macro, but there was some black stuff on here. I've cleaned it off with the cotton bud, but I spotted it straight away and I was like, what on earth's that? So I cleaned it off here, and then I noticed in the light there's actually a crack in the middle of that capacitor. Yeah, so we're on macro. Hopefully you can see there is a crack in the middle. That capacitor has gone. It's 220 nanofarads, so I'll need to swap that out. The other thing I noticed as well is the solder point on this side is really dull. I've just been cleaning this with the scratchy tool there, but also the fiberglass pen, and one or two of the pins on this side of the CPU socket here, or the CPU card socket, are really corroded. So yeah, some corrosion has gone there. I don't know how I missed that the first time around. That capacitor is really mysterious. One thing of note is when you use ATX power supplies with something like this, they can generate an awful lot of current for the 5-volt rail, something which the original power supply would not have been able to do. So when you get problems with shorts and things, whereas with the Amiga, the original Commodore A4000 PSU, you may find the power kind of cuts out, it doesn't do any damage. But on an ATX power supply, traces can absolutely vaporise from that, the extra power that it's capable of drawing should a short occur. So yeah, that's just something to bear in mind. Anyway, that's come out really clean there now, so I'm happy with that. That is not the end of the world. Just get a bit of IPA on there. I just used a bit of vinegar initially, because clearly some electrolyte or something had got onto that at some point in the past. Let's just see if this breaks in two. That solder point there though is like dark grey. So it smells when I'm heating it there as well. It smells burned. So yeah, I think it's fractured and shorted, doesn't it? Yeah, the pad's not there. Look, pad's not there. I just literally touched that and it just came straight off. So, but that's what I suspected. It smells burnt. So at some point I think that has become a short, and ultimately the trace has gone there. But I mean, I can fix that. I can just see where it goes there and just extend it out a little bit, and get a hang on, get a bit off there. Yeah, get a new capacitor on there. It's just really weird how at any point during testing it didn't give me any clues. I never smelt any burning or anything like that, and I just never noticed it. I'm sure there's no pad there. I think heating that is just fruitless exercise. Yeah, look, but that pad's alright. Yeah, that one's fine. So yeah, that's really odd. So it's not exactly the same size as the other one. It's, you know, subtly physically smaller, but it's 50 volt. Oh, hang on, I've sucked it up the tube. Look, it's 50 volts, 220 nanofarad. Let me just try and get that off there. Yeah, I was just trying to get a little bit of flux on there. There we go. I've achieved that anyway, but yeah, we've got it everywhere in the process. Look. Yeah, you might want to maybe stick a tiny dot of epoxy under it or something like that. Let's just use this. We can put some flux on there and reflow it in a second. I just want to make sure it's actually joining. Yeah, that's not so bad. So let's get a little piece of kynar and join it up to the other side. We'll just get a little bit of solder onto that side, like that. So I'll bend the wire at 90 degrees. Hang on. That's fairly flat. Just so that it would make a connection with the side of it. And then we just need to snip this down to about the same length as the pin. Like that. Yeah, that's melted back a little bit. And just pull it down to the pin there. And just heat this and join it up. What I might need to do is just push it into position a little bit. Just check that with the magnifier. And the one we took off, if I just hold that there like that, can you see that? Almost 5K. It's turned into a resistor. So yeah, that's why the board was charred, and ultimately why there's a crack in it. Well, the crack is probably the actual thing that's caused the damage, but it's, that's turned into a resistor. It's turned a cap into a resistor there, and you can see the pad there. It's burnt. Yeah, I'm not sure how well it's going to focus. It's black, absolutely black on the underside of it. So yeah, at some point that has shorted. So that little fix there worked a treat. So just testing out the A board now, the one I'll be keeping, I think. I love the Amiga version of this, it's really good. The only version that's better than this, home version, is the PC Engine. Oh, crashed straight to the curb. Elite did one or two really good games on the Amiga actually. I quite like their port of Ghosts and Goblins. It's not as good as the C64 version, but I don't think anything is in my mind really. Oh, it's so hard. Oh, how did it get me twice? Now this game I think I played on my 500 Plus actually, and I got the 500 Plus just after the Mega Drive. So I'd already played it on the Mega Drive. The Mega Drive version's definitely superior. I think the music in places is better on the Mega Drive version as well. But still, I think the Amiga version is very good, it's a good port. So here's a quick final look at the A board. So this is the one that Stephen Leary has let me keep. So this is fantastic. Yeah, fixed 2020. So this now means I have my own A4000 board. Thank you ever so much to Stephen Leary. The underside of the CPU card needs a bit of a clean. That's one thing I haven't done. But yeah, the top side that was recapped there. I kept the one that was. Can you see the solder's not quite as good as on the other CPU card there, but it works fine. You know, this is the one that had a little bit of corrosion around here. So again, I gave Stephen the better CPU board. I'll just put the CPU board out of the way. So I've got my own Kickstart 3.1 ROMs on here now. I'm trying to remember exactly the faults on this board. I mean, it's had some brand new 245s here. Obviously those were swapped around between the boards at various points. None of them were faulty, thank goodness. This is the one where we were missing, you know, all the pads. You can see in the middle here, all the pads were gone, so there was nowhere to mount that IC. And I just opted to mount it piggyback style, you know, because there's about 5 or 6 or 7 pins that join to the chip below, and again, you know, tinned all around the connections and things there. There's some copper exposed here on this one, but yeah, I'm not too bothered. This is just one, you know, to keep for myself, and that had been swapped out by someone previously. So what I could do is reposition it. Can you see it's crooked? That's not something I've done. It was already like that. I just cleaned up the solder points a little bit, but the legs were kind of a weird shape here, and you can see it's still like that. So yeah, if I got bothered by that, I could take it off and fit a new one. And again, it was a similar thing here where somebody melted all the sides of these and I've just smoothed them down. Can you see? They're dead straight. The other thing I did, which I did not capture, if I just take the sims out, yeah, that's a burn from the desolder, you know, hot air. I burned myself the other day on it. The other thing I didn't show, I think it was the third slot up here. This was not making a grip on this side because it had been heated on this board. So all I did is set the hot air to about 250, and I heated there for a few seconds and just gently pushed with the screwdriver, and it moved just a tiny little bit, and let it cool, and then put the sim back in, and after doing that, it now grips on this side. So yeah, that's just a little tip for you. I've got one gold plated sim here, and I'm putting that down here because this slot was the dirtiest. And the slots on this one were dirtier than the one I gave to Stephen, to be honest. I had more problems trying to, you know, get these cleaned here to make the RAM work properly on this one. Now I could swap out the sim slots at some point in future. Someone kindly pointed out that whilst the direct 45-degree replacements for these ones that slant like that, they're about £10 each, you can get the upright ones that are just like a couple of pounds each. So the only thing you need to bear in mind is if you've got, in a case, they're going to sit like that. So depending on the height of your sims, you might have some issues inside your case. But yeah, you can still get the 45-degree ones there. To be fair, they're probably not 45 degrees, they're just slanted, aren't they? Yeah, and you can see, even though that's an original socket, it is bowed, as I mentioned earlier. So again, the CR2032 mod to this one. This one needed a real-time clock. I replaced the 174, so 2 new 166s there. I did replace the one below and redid the initial work I did around there. You can see, whilst there's blobby-looking connections and things, you know what? It's alright, but I opted to keep this one, and I think I sent Stephen the better one, although this one's not had anywhere near as much stuff done around here. I felt that this would be easy to knock and damage when you're using the board to test things. The other one, the chip was mounted here, but I don't know, I just felt it was more robust. And again, I think I had the odd damage connection around here. Now that wasn't the case with Cather's board. Cather's board was a lot easier to do. And again, like the board I sent back to Stephen, I didn't reflow everything around here. So that could be reflowed. I could get some flux and solder on there if I wanted to. And there might be just the odd little bit of copper exposed. I'm sure there probably was on the one I sent back to Stephen. Like, I can see one there. Can you see that? There's just the odd little trace that I could spend some more time tinning those up, but I'm sure it's going to be okay. The one thing I did notice, and I'm disappointed because this is my mistake, the board I sent back to Stephen, I thought that it was the other way around. One of these, I removed the resistor pack. It was the only other thing that hadn't been removed around here. I cleaned up the little diodes here. They look like transistors, but they're not. And I cleaned up all the caps and everything around there. But on one board, and I thought it was this one, I needed to remove the resistor pack. So this one has been removed. Can you see that? It's nice and clean. And that's the problem. So I've just realised that the one I sent back to Stephen, That's the only thing that hasn't been done. If he looks at that resistor pack there, he might go, oh, that hasn't been swapped, pulled off yet. There's a few dirty looking pins. So I would say to Stephen, if he's bothered about that, just desolder that resistor pack and just clean with the cotton bud and stuff, and then put it back on again. So same thing down here, was a bit fiddly doing the inside of there, but yeah, caps replaced. Some of them just the same on both boards. Can you see got a bit of Kynar there? This is the one I showed earlier in this video, I think, where we got a piece of Kynar there and a piece of Kynar on that side, because the pads are just completely gone on it. This is the second board that was having clock problems. The first one, it was just the crystal, and I think I've swapped them around, but it might be this one actually. This might be the one that wasn't booting at all, and it's got a brand new 50 megahertz crystal there. So I did have to get a crystal, but I also swapped that 7.4, and after doing that, and realising that one of these needed, well, both I think those needed to be on there, that's when this board sprung back to life. Quick look at the caps at the back there on this one, all super clean and tidy. Now, the fact that Stephen has allowed me to keep this is just unbelievable. I am so overjoyed, I really am, because I've got the flagship Amiga machine. The only thing I need obviously is a case. If I can find a case somewhere, even if it's a bit beaten up, if you know of one, please let me know. If you've got one that's a bit scratched or the paint's chipped on it or something, please let me know, and I'm sure we can come to some sort of agreement. But the amazing thing is, look at this. He sent me this as well. What a great guy. What a great guy. So yeah, I can now connect my Zorro 2 and Zorro 3 cards up. So I just need a case. A power supply I can sort out one way or another, and I've got floppy drives that I could fit in the case. Just need to find a case. And here's the bag of all the bits. So, a couple of real-time clocks, crystal, 2 lots of caps sets here for the boards and the CPU cards. We got a 245 down there, I think. There's probably a couple of 166s in there, and some 174s, HC04, and an F86, I think, or something like that, which relate to the Buster thing, and you'll see that in the live streams. And if you don't want to watch the edited live streams later, the yellow screen, this is the Fat Buster here, and I've looked at everything around here, and I did probe lots of things, couldn't make sense of it. But ultimately, after I socketed up that chip and put the other chip on there, proved that it wasn't actually the chip, we were left looking at this here. So again, I would suggest that if you've got a yellow screen problem on one of these corroded A4000 motherboards, check out the 74F86. It's fairly just near the battery area there, so that can be affected by the corrosion. So I'm sorry this video has been the worst of the series in terms of it being a bit bitty. I cut so much stuff out and it's been jumping around, and that's the way I worked on these boards. I was jumping from one place to another, just making gradual progress in different areas, until eventually everything was 100%. So special thanks to Stephen Leary for sending these. I do hope you've enjoyed the series there. I will edit the live streams down to sort of more manageable, watchable versions for my Patreons initially. I'll also try and, over the next few weeks and months, get some more Patreon-only content up there. I'll perhaps start with some basic tutorials on components and things and soldering techniques and that sort of stuff. But yeah, I'll try and put some more emphasis in towards more Patreon-specific stuff, just as a way to say thanks really for the support on Patreon. Because without Patreon and without donations like this to the channel, I would have nothing. I wouldn't be able to show anything. I wouldn't be able to do hardly anything. So yeah, all of the support that you guys provide and Stephen Leary has provided is much appreciated. And as an extra bonus here, you can see it's working with the A2091, and it has booted from the SCSI to SD there fine. Fantastic, thanks for that, Stephen. I'll catch you in the next video.